Today, let us see theorems about cyclic quadrilateral. What is the definition of cyclic quadrilateral? You must know that when all vertices of any quadrilateral, 4 vertices of quadrilateral are on the same circle, then it is called cyclic quadrilateral. And opposite angles of cyclic quadrilateral are supplementary. We have to show that the opposite angles of cyclic quadrilateral, sum of their measures is 180. So, in given part, we can write simply ABCD quadrilateral, it is cyclic. And to show that opposite A and C are opposite angles, their total is 180. B and D, sum of their measures is 180. We have to prove this. Now, we have to remember about angle A. What about this angle A? Where is the vertex? It is on the circle. So this is definitely inscribed angle. And the measure of that angle, it is related with its corresponding intersected arc. That is called inscribed angle theorem. So we can write the measure of angle A. What is that? Measure of angle A is half the measure of arc BCD, measure of arc BCD. By which theorem? Inscribed angle theorem. Similarly, let us find out the measure of angle BCD, measure of angle BCD. So, again it is inscribed angle. Measure of angle C, we are using that BCD is angle C. And what about the intersected arc there? It is BAD. So, by inscribed angle theorem, half of arc BAD. Same reason, inscribed angle theorem. Now, we have to find out the total sum, measure, addition of measures A and C. We can add them. Therefore, from 1 and 2, if we add angle A and angle C, we can add right hand sides. What about the right hand side? It is half the measure of arc BCD plus half the measure of arc BAD. From 1 and 2. When we add them, we are getting measure of angle A plus measure of angle C. Half is common. And inside the bracket, when we take half common, what is that? Measure of arc BCD plus measure of arc BAD. We can see that BCD, this is BCD arc, and BAD arc. Together they are forming circle, and the measure of circle, we know that the addition is 360, so we can substitute. It is 360. So measure of angle A plus measure of angle C is equal to half into 360. Measure of circle it is 360, and we can calculate the half of 360 is 180. So this is proved here. What is that? 180. Measure of angle A plus measure of angle C is equal to 180. Similarly, we can prove the remaining. Opposite pair B and D together total is 180. We can prove that. So we have to write that. We can prove B plus D is 180. So this is known as cyclic quadrilateral theorem. Opposite angles are supplementary. Now about the same quadrilateral, let us say another one about exterior angle. So it is exterior angle of cyclic quadrilateral. A, B, C, D, it is cyclic quadrilateral given. D, C, E, it is an exterior angle of the triangle. It is exterior angle of quadrilateral, exterior angle of cyclic quadrilateral. So we have to find out the measure of this angle DCE. We have to show that it is congruent with BAD. So this is opposite to the adjacent interior angle. So this is adjacent interior angle of exterior angle, and we have to show that the exterior angle is congruent with, what is that statement? You can read carefully. It is congruent to the opposite of its adjacent interior angle. So we can write down proof of this theorem. What is that? BAD angle, BAD plus DCB, we can use this theorem. Opposite angles of cyclic. So what is the total? Definitely it is 180. So we can write opposite angles of cyclic quadrilateral. They are supplementary. Now we can find out the total of DCB and DCE. You know that the total linear pair. So it is 180 linear pair. And right hand sides are equal, so definitely left hand sides are equal. So what about that left hand sides? Angle BAD plus angle DCB is equal to angle DCB plus angle DCE from 1 and 2. But you can see that left hand side DCB, right hand side DCB, eliminated. So what is that we are finding here? Angle BAD here, left hand side. Angle BAD is equal to angle DCE. And when the measures are equal, definitely we can write angle BAD is congruent with angle DC. So if we use that number 3 here, so we can use that from 3 angles are congruent. So this is exterior angle DCE, and it is congruent here with which angle? angle BAD, and it is opposite to adjacent interior angle. This is adjacent interior angle of exterior angle. So this exterior angle is congruent here. The statement is very interesting. You read that statement again and again. So two theorems are there about cyclic quadrilateral. First one, opposite angles are supplementary, and second one, exterior angle of cyclic quadrilateral. It is congruent with which angle? Opposite to its adjacent interior angle. So try to revise again and again. Important theorems are there. Okay.